Good morning. Welcome to our lecture series. Today our topic of discussion is on coordinate system. What is a coordinate system? Why it is required? A coordinate system is important in mathematics and physics and engineering so as to exactly define the position of points, objects or fields which are in interest either in space or somewhere. It provides a systematic way to describe the locations and movements. What is the purpose of the coordinate system? It is particularly meant for precise location representation. Means it helps to define the exact position of an object in space. For example, GPS system uses latitude and longitude to locate the places. And mathematical representation of physical quantities, which is used to describe the vector fields and force mathematically. Example, electric and magnetic fields are also represented in coordinate form. And motion analysis allows us to analyze the motion in different frames. For example, projectile motion that uses Cartesian systems to track the path. And navigation and mapping, whereas to guide the movements in space. For example, airplane rotors are mapped using spherical coordinate system and used in CAD drawings and also in modeling, scientific computations and simulations. For example, weather forecasting models also uses coordinate systems to represent atmospheric and weather conditions. And there are many types of coordinate system: Cartesian, polar, parabolic, cylindrical, spherical, uh, hyperbolic, and many more. So our interested topic is of Cartesian coordinate system and cylindrical coordinate system and spherical coordinate system. Cartesian coordinate system is otherwise known as rectangular coordinate system. All the systems has three coordinates. So every object has been described in these three coordinate systems. It is the rectangular system that uses grid-like structure so as to identify the position of any object. It is used for rectangular grids, for example, city maps, pixels, etc. Each coordinate system is used based on the nature of the problem or the surface under interest and the symmetry of the object or the phenomenon that is being analyzed. Cartesian coordinate system has three coordinates, namely x, y and z. This is used when dealing with rectangular or grid-like structures, helps in defining straight line motion and linear relationships, and ideal for problems in physics, engineering and computer graphics. GPS mapping, we know the position of locations on a city or map is represented using XY coordinates. Motion of a car moving on a straight road can be analyzed using Cartesian coordinates, and screen pixels also so as to identify the exact location of the pixel in the Cartesian grid. And building architecture, it is obviously a three-dimensional art x, y and z, like length, breadth and height, so as to design the buildings. So the next one is the cylindrical coordinate system. The coordinates are r, theta and z. It is used when dealing the objects with circular symmetry or a circular-like structure. Helps in analyzing problems involving cylindrical structures and circular motion. This simplifies equations of circular and spiral paths. For example, all the pipelines, cables, optical cables, and oil gas pipelines, the structure of long cylindrical pipe is you analyzed using this cylindrical coordinate system. Spiral staircases, the shape and design of the spiral staircases also follow cylindrical symmetry. Electric motors, that is the rotating magnetic field inside an electric motor, is exactly represented in cylindrical coordinates. And in medicine, DNA structure is a helical structure of DNA is analyzed using cylindrical coordinates. The third one, spherical coordinate system. The coordinates are r, theta and phi. This is used for objects and phenomena with spherical symmetry. For example, it exactly helps in studying the planetary motion, gravity and electromagnetic waves. It simplifies equations involving spheres and 3D waves. Planetary motion, the movement of planets and satellites around the sun, follows a spherical coordinate system or a spherical path or orbital path. The radars uses spherical coordinate system to detect the position and distance of the aircraft. Sound waves propagation, waves spreading in all directions. It is not restricted. It moves in all directions, and it is best analyzed using spherical coordinates. And magnetic and electric fields, the distribution of electric and magnetic fields around a charged sphere is analyzed using spherical coordinate system. So these are the orthogonal, that is unit vectors in such system of coordinates are mutually perpendicular in the circular way. So this is the simple graphical representation of rectangular coordinate system or Cartesian coordinate system. So we know the three planes are x, y and z. We have three planes, xy plane, yz plane and xz plane. So the three unit vectors ax, ay and az. So at xy plane z is equal to 0, at yz plane x is equal to 0 and xz plane y is equal to 0. The unit vectors are ax and ay and az in three directions x, y and z respectively. So consider this diagram. If the point P is at a distance x from origin, then if the components of vector r along x, y, z are x, y and z, then vector r can be represented as xax plus yay plus zaz, whereas which is equal to the complete magnitude r into ar. Equation of vector AB, OA, vector OA is equal to a distance, where A can be represented as AX, AY plus AZ. Similarly, another vector B, which is located at point B from the origin. OB is equal to B. It can be mentioned as BXAX plus BYAY plus BZAZ. Then the sum of the two vectors, vector A and vector B, is equal to AB. Dot product and cross product. Dot product is nothing but the scalar product, and dot product is nothing, cross product is the vector product. Dot product is AX plus AY plus AZ dot BXAX plus BYAY plus BZAZ, which is equal to AX plus AY plus AZ BZ. Here the unit vectors of similar direction gives 1, and whereas the unit vectors in a dissimilar direction gives 0. Similarly, cross product or vector product A cross B is equal to AX plus AY plus AZ plus B cross BXAX plus BYAY plus BZAZ. A cross B can be represented as matrix representation of 3 cross 3. There is the unit vectors in the first row, ax, ay, az, and magnitude of vector a in the second row, and magnitude of vector b in the third row, like ax, ay, az, and bx, by, bz. So this gives the cross product of vector a and vector b. The answer is some numerical value if all these three vectors a, b and c are non-zero. A dot b is equal to 0 means then cos theta equal to 0, theta is equal to 90 degree. Therefore, the two vectors can be mentioned as perpendicular vectors. The condition for two vectors to be perpendicular is A dot b must be equal to 0. Next is cylindrical coordinate system. So the cylindrical coordinate system is easily applied for the surfaces with cylindrical in structure, like a pipe, as I mentioned now, a gas or oil pipe. Even we may consider the gas cylinder what we use at home, which is given by a pipe to the stove. So this is also a cylindrical like structure, and spiral staircase and electrical motors and DNA structure. All these are cylindrical coordinate in structure, and this can be analyzed using the cylindrical coordinate system with the coordinates r, theta and phi. This simplifies the equations of circular and spiral paths, which is very complex. So next is the spherical coordinate system. This is easily applied so as to study the planetary motion or gravity or even electromagnetic waves. Electromagnetic waves always travel in spherical like structure. Why? Because the E and H waves travel perpendicular to each other in the atmosphere. This is used for the objects and phenomena with a spherical symmetry. The planetary motion and the radar and sonar, the propagation of sound waves and electric and magnetic fields, all these are analyzed using the spherical coordinate system. When we know the sound waves propagate in all directions, so this can be analyzed in the best way using the spherical coordinate system. So this is the del operations over a vector. This del triangle is known as del gradient of V, where del is nothing but dou by dou x, ax, dou by dou y, ay, dou by dou z, az. So the gradient operators or the del operators are gradient, divergence and curl. This del V represents the gradient of vector V in Cartesian system. Dou by dou x, ax into V, dou by dou y, ay into V, dou by dou z, az into V. In cylindrical it is del V is equal to dou by dou rho, a rho into V, 1 by rho, dou by dou phi, a phi into V, dou by dou z, az into V. Whereas in spherical, a gradient of V can be represented as dou by dou r, ar into V, 1 by r, dou by dou theta, a theta into V, 1 by r sin theta, dou by dou phi, a phi into V. So this representation is important while solving the numerical problems. The next is voltage with respect to the radial direction. If the element under consideration is a lengthy wire. So in a lengthy wire, the charge density which is associated with the entire conducting wire is rho L. Therefore, the voltage which is experienced or which is measured is equal to 1 by 4 pi epsilon naught integration line integral rho L dl divided by r minus r dash. Right? Similarly, if the surface under consideration is a plane or a sheet or a panel which is of uniformly charged, then the voltage through that device is equal to 1 by 4 pi epsilon naught surface integral rho s ds divided by r. And if it is a iron ball, then it can be correlated with the volume charge density. Therefore Vr is equal to 1 by 4 pi epsilon rho v dv integral v divided by r. So this is the various charge distributions of different elements like a wire or a sheet or a sphere. So based on the structure, the charge density also varies. Hope you understood this session. Thank you, students.